Welcome to the tutorial video, Producing Marine Canvas in Rhino CAD from PhotoModeler Exports. In this video, we show how a boat measurement that was done in PhotoModeler can be used in Rhino CAD to produce canvas panels for cutting. We show exporting the data, importing it into Rhino, creating canvas panels for a Bimini and sprayhood, and provide a quick overview of some of the 2D CAD processes. We finish by showing a CAD rendering for client review and the finished product. Note that this video focuses on the initial stages and how to use the PhotoModeler data in Rhino and does not go into detail on the whole canvas CAD process. Resources at the end of the video outline how you can learn more. We have a completed Larson project loaded in PhotoModeler. The project used coded targets, offsets, points, and bent tubes. This project is courtesy of Seaside Marin at seaside.nu. We've set up layers to help organize the project as shown here. Now we'll export the data. Choose the Rhino 3DM format. For items to export, choose points, offset points, lines, and bent tubes. For settings, ensure that Bent Tubes As is set to NURBS for center lines and surfaces. Press the Export button and choose the location and file name. A summary of the export is shown. We'll go through how to take the output from PhotoModeler and use Rhino CAD to transform that into production-ready patterns. We go to the File menu, pick Open, then choose our exported model file. You may not see the imported data as the views are not scaled correctly. We right-click on the Zoom Extents tool, and that will zoom all 4 of our viewports to the correct size. Now maximize the perspective view and change it to shaded. The shaded view will give us additional depth perception when looking at surfaces. We'll hide some of the things that we don't need right now. We're going to hide the points and lines. PhotoModeler can export the tubes as both surfaces and center lines. We don't need the center lines right now, so we can hide that layer. Let's zoom in and look at this front tube. We use the Extract Isocurve command to draw a line on the outside of this tube surface. To do that, we can type in Extract Isocurve, or if you prefer using icons, open the Help tab and it will automatically update with the current command. Here it shows you where the icon is and what menus you can find it on. We need to select the surface for Isocurve extraction. Next, we select a point on that surface. If your isocurves are going in the wrong direction, simply toggle the direction parameter. If it's going in the V direction, you'll see the curve wraps around the surface. We'll use the U direction, and you will see the curve going in the right direction and full length of the tube. We want to put the isocurve right on the outside edge of the tube. Your preference might vary. We press Enter when done and move on to the next tube. Once we have all the isocurves extracted, we can begin to work on the frame for the Bimini. There are a few accepted ways to choose the location of the isocurve on the tube surface. You want to consider seams, pockets, canvas stretch, etc. We won't go into detail on the various placement methods. You may have a technique already for seam placement and canvas sizing that you can work with here in 3D CAD. The method shown here uses the part of the tube that is away from the fabric stretch, what we call the outside edge. That is, use the rear top of the tube for the aft tube in the Bimini and the front top of the tube for the fore tube. The middle tube isocurve placement may depend on the pocket and how the tube will naturally fall due to gravity. You can also modify the canvas panels in 2D to reduce wrinkles, potentially with a script to automate. Return to the Layers panel and hide tubes. We show only those outside isocurves that we drew. To get these to the correct length for the Bimini canvas panels, we need a horizon line. We're going to draw a horizon line based on visuals. Right-click on the polyline icon to get line segments. Draw this down the edge of the Bimini. Because this project was imported with a correct rotation, we can go to the right view, select the horizon line, and use the trim command. Make sure that the apparent intersection option is on, and apply the trim to the tubes. If your line doesn't reach the end, you can use the extend command. Select the line to extend just past the tube. Now we can go back to our trim command. Use that as a cutting object and cut the apparent intersection with the other side. We repeat this at the other end. Going back to the perspective view, we can delete those lines that are extended and redraw. We draw the line segments on the other side as well. Now we have the wireframe for the Bimini top. There are a few methods for defining the Bimini horizon line. Here we show a visual method in CAD. You can also put some tape or dots on your tubes at the horizon before photography and model them in PhotoModeler. In addition, you might need to consider if the mid-tubes taper in, and instead of joining the horizon to those mid-tubes, draw an outboard line from first to last tube. This might let the canvas fall more naturally and join to the side curtains well. We now have the completed wireframe for the Bimini. To keep organized, we'll make a new layer called Surfaces. Make this the current layer by moving the check mark over. We start creating surfaces using the Sweep To command. We'll use the long sides as the rails. Select the first rail and then the second rail, and select the other sides and the sweep shapes. Before continuing, we will address an important aspect of working with 3D canvas in CAD. The end goal of any canvas project in CAD is to cut two-dimensional canvas panels that can be sewn together to form a 3D structure. With PhotoModeler and the first parts of the CAD work, the process is in 3 dimensions. To generate 2D shapes from 3D surfaces, we must flatten 3D surfaces. In addition, you want to flatten your surfaces so there's minimal distortion or fabric stress. This can be done from 3D meshes using an extra plugin, but we do not address that here. A 3D surface that can be flattened without distortion is called a developable surface. In Rhino, we can create surfaces with different commands. Here we use the Sweep To command because it's easy to understand. One can also use loft surfaces with developability control. A developable surface is curved in one direction and flat or straight in the other. So you can use the curvature command in Rhino to check if the surface looks developable. And when we flatten the surfaces using the Unroll command, we can check for the amount of error. We continue the process of using Sweep To on each Bimini section. If there's a twist in the result or something about the shape you don't like, you can add additional sweep lines to the surface. We will delete the surface and add additional line segments. We turn off the knot snap so we can add the line where we want along the curves. We add 2 line segments. Then, using the Sweep To command again, choose the rails and 4 sweep shapes. This method can be used to control twists in the surface. The last thing we need to check before unrolling these is that the correct side is facing outwards. All surfaces in Rhino have a front and back side. We check this using the Analyze Direction command. You can see that this surface is pointing outward. All surfaces look correct. If one was not, we can use the flip on the command to change its direction. Another way to check is to use shading options. Pick the Options tool, View, Display Modes, and Shaded. Set backface settings to a single color for all backfaces. We'll leave that color as orange. Now when we look at the model, it's obvious which side is the back and which side is the front. Next, we'll start building the rest of the wireframe so we can generate our front curtains and back sides. Set Current Layer to default where we are building the wireframe, and turn off the Surfaces layer. We have only the default layer and the Snap Offset Points layers on. First, we show creating an interpolated curve to smooth out the points. Get the Interpolated Curve tool and start tracing the snap points. You might use this to improve the bottom canvas line. Alternately, a faster method uses the line generated by PhotoModeler. Turn on the PhotoModeler Lines layer. We join the front half by selecting just those lines, as we want to keep a sharp transition front to back. Pick the Join command to make one polyline. We repeat that for the back snap line. Now we can use the Curve Through Polyline Vertices command, a degree 3 curve and interpolated. Repeat that for the back. Now we have a nice interpolated curve through the snap points. Hide the lines and show the snap points for reference. Next, we add lines to break up the canvas panels for the front. Connect this corner to the front snap here. We do the same thing for the other corner, and connect the back of the panel here down to the break. For the back, we add lines to similar snaps on either side. We'll add windshield panels now. First, return to the 4 viewports. We want to draw vertical lines from the snaps curve to the front tube. Pick the Line command, and using the front view, we create a vertical line. Repeat for the other snap. Next, we'll clean up the wireframe. Maximize the perspective view. Select the front tube line and holding Shift, the front snap line as well. Run the Split command and select the front panel dividers. Now you can see each line is split for the panels. This will help when we build the surfaces. Repeat the same line drawing and splitting in the back. To produce one side curtain surface, we need to join the lines on the top. Repeat for the other side. Now we have a clean wireframe model to begin building the surfaces for the curtains. To build the curtains, we again use the Sweep To command. Use the top and bottom curves as the rails and the sidelines as the sweep shapes. As you can see, the back of the surface is facing the outside. We select the surface and right-click to get the Flip Direction command. If you get twists in the panel, you can add additional lines as shown before with the Bimini. As mentioned before, we can check curvature to ensure it is a flattenable surface, or check for errors in the Unroll command later. We continue this process for the rest of the windshield. We repeat for all the side curtains. Note, you can select multiple surfaces and flip them all at once. We can now begin to unroll or flatten our surfaces. We unhide our top surfaces that we created earlier. Using the Unrolled Surface command, we want Explode set to No, Labels set to Yes, key properties set to yes, and leave relative tolerance at 0.01. Select a surface to unroll or flatten, and press Enter. We check the amount of error in the unroll. We see it is 0.17%. If it was close to 1%, we would look to see if we could improve the developability of the surface. You can see the surface has been unrolled to here at the origin. Open the 4 viewports. Turn on Gumball modifier if not on. We drag the panel away by selecting it and dragging the mouse. Then we rotate the panel by selecting and dragging on the blue rotation line. This gives it a rough orientation to help with organization. We unroll the next surface. Use the label numbers to ensure the surfaces are oriented correctly. Repeat the unrolling for the rest of the model. With all the surfaces unrolled, go to the top view. Hold down Shift and select all the groups. Drag the panels away and tap the Alt key to create duplicate copies. With our copies, select all the panels and use the Silhouette command. This creates a line border around all the panels. After creation, the borders remain selected so you can drag them or drag an Alt key tap to make copies. We now have the panel outlines, the same as if we started with a 2D patterning method. Switching now to the completed file, the process here is the same as a typical 2D canvas in CAD process. We can add our Bimini pockets and glass panels. We can add any seam allowances, match marks, and zipper marks for our side curtains. Some of this can be automated too with scripts. Shown here is a finished sewing map with some labels. We can then go through and prepare this for final production, including using nesting software to make a nested output file like this for a cutting table. With details added in 3D to split the windows from the curtain panels, we switch to the rendered view and apply some materials. This allows us to visualize what the finished product will look like. We can even change colors to give the customer a different preview. With the rendered 3D canvas, we select the rendered section, go to File and choose Export Selected. This gives us a file with just the rendered model. We switch back to PhotoModeler so we can export the photographs to Rhino and use as background wallpaper. You can do this export in PhotoModeler Standard or Premium, but note that only Premium has the capability of idealizing. Idealizing a photo removes all the lens distortion so that an external program like Rhino, which uses an ideal camera model, can render correctly and match. Exporting photos from Standard will work, but the match won't be as good in Rhino. We'll quickly demonstrate using Premium for this step. We're going to re-export the file with a few camera views. Go to the Photo table. While holding the Control key, click to select the photos you want to export. Right-click and pick Photo Set from Selected Photos. Use the Invert Selection tool on the table. Add a new layer called Photos Do Not Export and put all selected items into this layer. Go to the Idealized project tool and pick the photo set called One Photos. Press Execute. This will idealize just the photos to be exported to Rhino. Reprocess the project afterwards. We will now export again. Choose Rhino 3DM. In Layers to Export, ensure that the Photos Do Not Export layer is not checked. Go to Items and select Camera Views and optionally turn off other items. Then press Export and choose your file name. We open the 3DM exported from PhotoModeler that has the Idealized camera views. We pick one of the views in the Rhino View dropdown. We can drag the new 3DM file directly from the File Explorer onto Rhino. Pick the Import File option. You can now see the rendered model on top of one of the photos exported from PhotoModeler. It matches the geometry quite well. Switch to a different view. In the View Properties panel, go to the bottom. Turn off the gray wallpaper option to see the background photo in color. Then change to a rendered view. What a great client presentation tool, and all before any canvas has been cut. This is what the completed canvas looks like. While this canvas was created from the PhotoModeler dataset shown, it was not done with the exact CAD process shown, so there are some differences. To learn more about the CAD processes in Rhino, training and support from AP Consulting can be helpful. Adam from AP assisted with this video. In addition, the Getting Started videos from Rhino are a good place to start. The free nesting plugin shown at the end of the 2D processes is called Open Nest. In this video, we showed exporting a boat measurement from PhotoModeler and importing it into Rhino. We showed the creation of 3D canvas panels on tubes and snaps. And we showed a quick overview of the 2D processes needed to get a canvas cut file. We ended with a client presentation rendering and a list of resources.